Hello everyone, welcome back to ANSquare-Academy. Today we are going to discuss conservation of momentum. Conservation of momentum means momentum is going to remain unchanged before the collision of the objects and after the collision of the two objects. We can discuss it with the help of an example. Let's say there is a ball A having a mass ma and it is moving with a velocity ua. U, that means it is initial velocity of the ball A. There is another ball B and mass of this ball is m. We are presenting it with mb and it is moving with the initial velocity ub. This is the situation before collision. So before collision, can you calculate the total momentum here? Mass of this ball is m and initial velocity is this. So the total momentum before collision is ma ua plus mb ub. This is the momentum of these two balls before collision. Total momentum of the two balls. And when these two balls collide with each other, FAB is the force applied by ball A on ball B, and in return FBA is the force applied by ball B on ball A. And now when the collision has occurred, ball A is moving with velocity VA, this is the final velocity, and ball B is moving with the final velocity VB. Mass is going to remain same, MA and MB. This is the picture going to be after collision. After collision, what we have changed? The velocity of their movement. Velocity VA of ball A, velocity VB of ball B. After collision. So after collision, what will be the momentum? MA VA plus MB VB. Here we have written before collision, here we have written momentum after collision. Can we write the expression for action force? FAB. FAB is the force which was applied by ball A on ball B. FAB. It is mass into acceleration, and acceleration can be written as change of velocity by time. Final velocity minus initial velocity by time, that is our acceleration. Similarly, we can also write the expression for force applied by ball B on ball A. Mass into acceleration, and acceleration can be written as change in velocities by time taken. This is the final velocity minus initial velocity upon time, that is our acceleration. Change in velocities upon time or rate of change of velocity is our acceleration. Substituted the value of A, that is acceleration, by this. Now according to third law of motion, we already know that action force is equal and opposite to that of reaction force. This is our action force, this is our reaction force. So can we write these values here? Cancel out this T with this T. Keep in mind this negative sign here, because action force is equal and opposite to that of reaction force. Now just rearrange the terms. This can be written as MAVA, this MBVB here with plus sign, MBVB equal to MAUA plus minus minus plus. Take this minus MB inside and minus UB here, it will become plus MB UB. So this is our momentum after the collision and this is our momentum before the collision. This means that the momentum is going to remain unchanged after the collision of two objects. It is going to be conserved, and that is our law of conservation of momentum. Here you can see the total momentum of the two objects remain unchanged after the collision. This is the value after the collision, this is the value before the collision, and they are equal. That means the momentum is conserved. The total momentum is conserved here. Now we can write the law of conservation of momentum statement. The law of conservation of momentum states that the sum of momenta of the two objects before collision is equal to the sum of momenta after the collision, provided there is no external unbalanced force. This is something what we have discussed here in this example of collision of two balls. So dear students, today we have discussed conservation of momentum with the help of this example, and we have also discussed law of conservation of momentum statement here. So if you have any doubt regarding this, you can mention it in the comment box. And dear students, if you have understood the concept, if you are getting the concept, then you kindly like, share and subscribe the channel. Thank you.